Hi everyone, we are gonna do lesson 8-2 today. Remember last week we started the units of logarithmic functions. We talk about the basic properties of the logarithm, like how to find the vertical asymptote, how to define domain and range, find the x-intercept, and basic terminologies, how to convert the exponentials to logs, all those kind of stuff. That was the intro. Today we are gonna see more algebraic stuff about the logarithmic equations, and we will talk about the properties of logarithms, like how to add, multiply, divide, and subtract based on some rules, which is similar to the ones that we have for exponential equations, like exponential properties. We'll talk about 3 or 4 important rules for that. So let's start with a basic one that we don't need a property at all, like how to solve a basic logarithmic equation. Then we can move on to those properties. So the first question is on page, by the way, we are on page 409. The lesson will start on page 409, so make sure it is open in front of you. So let's see the first question on page 409 again. It says log base 4 of x is equal to 5/2. We are looking for what x is here. Okay, so to do that, we are gonna need to convert this equation into an exponential equation. Remember how we do that? We had a rule from last week. It was saying that if we have the log b of x is equal to y, we can convert this logarithmic equation into an exponential equation by doing that. B stays same, y goes inside, x goes outside. So basically they switch. So b to the power y is going to be equal to x. So this is how we do, how to convert to the exponential equation. So basically we will do the same thing here. So since 4 is the base here, that will be a 4 here as the b, and x and 5/2 will switch. So 5/2 will be our exponent now, and x will be on the other side. There we go. That's how we convert to exponential equation, remember from last week. So in order to solve this one, 4 is a 2 to the power 2 that we know, and 5/2 here as still equals to x. Based on the product rule of the exponential equations, the 2 times 5/2 will give us a 5, so the equation on the left will be a 2 to the power 5, because 2 times 5/2 is 5 here, and is equal to x. And we know what is 2 to the power 5, that is 32. So x should be 32 in our first question. First we convert it to exponential equation and do the basic properties of the exponentials and find the solution. That will be the first question. Let's look at the second one. That's still on the same page, 409. This time, as you can see, we have two logs this time, one log on the left and the other log on the other side. So we have basic rule, not a rule at all maybe, but I would like to call it a rule. If we have log base b of anything, doesn't matter what you have here, let's say this is x, a big X, and that's equal to another log of b of something else, let's say y, or something much complex here. As long as you have the same log b's here, but it has to be same. If one is 5, the other can't be 4. It has to be exactly the same, just like in this question, log 5 and log 5. You can ignore these, and you can just say x will be equal to y. That's it. So when you see two logs together, you just eliminate the logs on both sides as long as they have the same number, like the b here, and that will be fine. So in this question, let me write it again. Log 5 of 2x squared minus 6 is equal to log 5 of 4x. So as we said, they share the same base. That means you can directly eliminate them and focus on this one. The 2x squared minus 6 is equal to 4x. That's what we will solve. Now this is not a logarithmic equation anymore. This is a basic quadratic equation, as you can see from the 2 here, the exponent 2, right? Remember how we solve them. We have to collect everything on both one side. Just subtract the 4x from both sides to do that. When you do that, your equation will be in the standard form, which is 2x squared minus 4x minus 6 will be equal to 0. Remember, do not try to combine negative 6 with negative 4x, as they are unlike terms, so we just put them together in the descending order of the powers. So this is what we have. Now let's remember how we solve this. We can just divide both sides by 2, because I believe 2 is what is common between all those three terms. When you do that, you will have an x squared minus 2x minus 3. That will be our quadratic equation to solve. Let's take this all up here. Remember, after this step, this becomes a quadratic equation. So we are just solving a quadratic equation, no logarithmic anymore. So x squared minus 2x minus 3. If we remember the thing, negative 3 can be broken into negative 3 and 1 like this. And then x squared will be x and x here. So if we check that out, that will be x minus 3, x plus 1. That will be equal to 0. And if you solve both sides, you will be able to find the first answer we got will be 3, and the second answer will be negative 1. So we got two answers here, 3 and negative 1. So remember what we do for the last time. We plug these numbers back into the equation to see if it's verifying or not. But before that, I would like to open a new page. We are here still, but I'm gonna add a rule about logs. Actually, something that we discussed last week. The rule is that when you have the log base b of x, remember the definition, b must be something greater than 0. It can't be negative, and also something other than 1. It can't be also 1. It can be any number, any positive except 1 for the b, the base. And also x, we have a rule for x. It has to be greater than 0 too. So, for example, based on this definition, here are some things that we can call as log, like log base 5 of 3, like log base 1 over 2 of 4, like log base 1000 of 2000. These are all good, so you can say so because the bases are greater than 0, other than 1, and the x is also greater than 0. But we cannot call these as logarithm, like log negative 4 of 3, like log 1 of 7, or maybe log 7 of negative 10. These are not cool. Why? Because if you check the first one and the second one, the bases are not good because we want it to be positive and we want it to be other than 1 to say it's logarithm. In the other one, if you see the x number here, that is something negative. It has to be also positive. So these are not log. So based on what we discussed here, when we plug the numbers into the equation to see if they verify or not, we have to see these rules first to talk about whether we have extraneous solutions or not. Okay, so let's go back to question. What we got, 3 and negative 1. Now I'm going to plug them back into this to see if it's verifying or not. Okay, so I'm going to put the equations again here. Log 5 of 2x squared minus 6 is equal to log 5 of 4x. Remember, we get x is equal to 3 first. Let's just check this one first. I will plug 3 into this and this. If we do that, it will be at 2 times 3 squared minus 6 and log base 5 again, 4 times 3. If you clean this one, prepare this, it's gonna be 5 of 3 squared is 9, 9 times 2 is 18, minus 6 is 12, and the other one will be also 12. So looks like this is good. Why? Because 5 is 5, greater than 1, greater than 0 and other than 1, and 12 is greater than 0. So this is good. So we can say x is equal to 3 is an answer. This is a real answer. Let's check out the other one that we have. we remember find that was as x is equal to -1. That's the other candidate solution. When we plug into the original equation again, let's see what will happen. 2 times -1 squared minus 6, is it really equal to log base 5 of 4 times -1? Let's do the math here. If you see what's 2 times -1 squared minus 6, you will see it's a -4, maybe in parentheses like that. And if you do the same thing on the right, you will also see it as -4. So looks like this looks good, right? -4, that's good. Log 5, everything's awesome. But remember the rule we just said here, the previous page. This is not log when we have the number here is less than 0. It's not cool. So when we check that, we have a -4 here, which is not helping us. This number here that I boxed must be greater than 0. Since it is not this, even though it looks like a solution, but actually it is not, we will call it again an extraneous solution. Remember what's extraneous solution mean? That means the fake solution. So we don't have this one as a solution. So we have only one answer. That will be just 3. 3 is our answer. -1 is not our answer. Okay. So let me summarize the question one more time what we did. We just skipped the log 5s. We made it look like a quadratic equation. Solved it the way we learned way back ago in the first quarter, maybe the second quarter. And we find answers 3 and -1. We talk about some rules that's related to logarithm. Based on them, we checked out that 3 is working, but -1 is not working. So we will have only one solution, that is 3. Alright, that's the end of the first 2 questions. Let's see now the second objective. We talk about how to solve a basic logarithmic equation, and second one, what are the properties of logarithmic equations. So we will have actually 4, but it's written 3 here on page 410. The first one is the product rule, the second one is the quotient rule here, and the last one is the power rule. Those are the most 3 important ones. We had the similar ones in the exponential equation. They have exactly the same name: product rule, quotient rule, and also the power rule. They had the same names. So actually they are corresponding to those 3 formulas here. Okay, so let's start with the product rule. Product rule says that if we have a logarithm can be written as multiplication of 2 numbers like m times n here, you will be able to break it into log b of m plus log b of n. So basically, if it is multiplied, you can write it as m plus n. That is rule 1. We call it product rule. For example, here we have log base 5 of 32, right? This is normally 32, and you can write the 32 as 8 times 4. And since this is multiplication, we can write 2 new logs as log 5 of 8 for the first number, plus, that's not multiplication anymore, plus log 5 of 4. As you can see, they still have the same base, 5, 5, 5. It doesn't change, it is fixed. It has to be same all the time. So you can break it into different logs as much as you want. Even if you can break the 8 and 4 and more, and have more log 5s here, that's totally fine. It doesn't have to be 2 only, it can be much more, as long as they all share the same log base. Okay, that is rule 1, product rule. When you have the things multiplied, you can break them as sum. That's the thing. Quotient rule will be similar. It's just like product. Quotient rule, exactly what we said is going to be valid here too. When it is a fraction this time, can be written as m minus n. Remember that was plus, now it is minus. So for example, in this example here, log 8 2 over 3 can be written as log 8 of 2 minus log 8 of 3. Just like we said for the product, if you are able to write more and more logs here in subtraction, that's totally fine. It depends on how you factor the given number that we have 2 over 3 here. question 3, I mean the rule 3, the property 3, we call it the power property. That's different than the other two. This time, if you have the standard number here as an exponential form, like m to the power n, that means you can drop the power n in the front. You see how the n was here, now it's in the front, it's not here anymore. Because n is dropped, you can drop the n, the power n in the front. For example, this one here. We have log 2 of 3 to the power 7. And guess what? 7 is dropped in the front. Now it is 7 times log 2 of 3. The exponent 7 is not up here anymore. It is in the front. We can do that. If it is the power rule, the exponent can be dropped in the front. That's the rule 3. Okay? So next coming questions, 3, 4, 5. We are going to remember these rules. We are going to use some of them maybe at the same time in the given questions. Okay? So let's see example 3. Before that, I would like to mention another rule. It's not given, but we will use it. So make sure you also note it somewhere under those 3 rules on page 410. The fourth rule is that we will use this a lot. If you have log b of b, that will be equal to 1. Always. How do you prove this? If you can convert this to exponential, you know that that's b to the power 1 is equal to b, right? Which is true, right? In exponential way. So if you have the base and the standard numbers same here, like b and b, that will be 1 all the time. For example, you have log 5 of 5, right? That will be 1. You have log 4 of 4, that will be 1. You have log 1000 of 1000, that will be also 1, right? This is the idea. Or you have log -7 of -7, that will be also 1. Even though this is mathematically correct, but remember the definition, this is undefined. It was just an example to see if you are paying attention or not. This looks good, but actually it doesn't make sense in log, because -7 is not good. It has to be positive numbers, remember. But the idea is that if you have the base and the standard number same, that will be equal to 1. That's what you need to know. Maybe one extra, I don't know if you will see this one, but if you have b of 1, this time you have a 1 here for sure, that will be 0. Okay, that's the other rule. Rule 1 here on 4 and rule 2. For example, log 5 of 1 will be 0. Log 1 over 7 of 1 is also 0, or so on like that. Okay, so that's the thing. But you will see this part more, that if you have the base and the standard number same, that will be equal to 1. Okay, don't forget that. Make sure you copy this one somewhere on the book. Okay, consider this one as rule 4. Product rule, quotient rule, power rule, and it doesn't have a name, maybe you call it base rule, will be fine. Okay, so now let's look at example 3. I will clean this one of what we have. Okay, so question is that log base 3 of 5, if you use the calculator, that's approximately equal to 1.465. That's what the question says on page 411. So based on that, what is log base 3 of 405? This is the question. Okay, so based on the rules we have, we are going to break this into smaller parts and use the number that is given us here. And we will link this to this one and find the answer. But before that, if you guys have a big number here like 405, make sure what is the factored form or the prime factored form of this big number. If they give you, you're lucky. If it's not, just find it out some way. Remember, in the CX we had the factor that we type on the calculator and write the number in. We were able to find the factored form. You can definitely do that, or you have to do it by your hands, and you will just see the breakdown here. But if you look at the book, what it says here, looks like 405 is equal to 3 to the power 4 times 5. Like 3 to the power 4 is 81 times 5 is 405. So what we will start with that given thing, log 3 of 405 will be written as this. No 405, but instead we will have a 3 to the power 4 times 5. Okay, so here is the part that we will start. Remember the rules again, page 410. Make sure you look at there and see which rule we can apply first. Product, quotient, power, or the fourth one. Right? Since it is the product, because we have a multiplication here, that we can break this 3 to the power 4 times 5 as log 3 to the power 4 plus log 3 of 5. Like this. The product becomes a sum here based on the rule 1. Okay, so now the 4 as the power here, right? If you look at the first part now, the 4 is the power exponent of the 3, so the 4 can be dropped in the front here as a 4 of log 3 of 3. That's the rule 3. So far we use the product rule, now we use the power rule. And on the other one, we don't have anything for this yet. We will use this later. And remember what I said about if it is log same number with the same number here, standard number. If they are same log BB form, log 3 will be definitely a 1. So you can cross it and say log 3 of 3 will be 1. So that means it will be 4 times 1, which is 4, plus log 3 of 5. Okay, so we know what's log 3 of 5 is given here, 1.465, and that will be our answer. If you add these to each other, you will definitely see it is 5.465, which will be our answer. Alright, next question, example 4. Similar, we are still given the same thing, but this time we are looking for what is log base 3 of 9 over 5, right? Same, we will break the 9 over 5 as log 3 of 9 minus log 3 of 5. Because of the quotient rule, the second rule, we have a fraction here, we have a subtraction here. And we also know that 9 can be written as 3 to the power 2, we already know this. And the other one is just same again, because it is simple enough. And we drop the 2 in the front here. That is the rule 3, the power rule. So it will look like log base 3 of 3 minus log 3 of 5 here. So far we use the quotient rule here. Let me write it, quotient rule here. The next one is the power rule that we use. And now we have log 3 Remember what we had for this one, log 3 is a 1. So this will turn into a 2 times 1. So that's a 2. 2 minus log 3 of 5 will be what we are looking for. So maybe I can say the rule 4 here. So now we'll just do the math. Log 3 of 5 is given as 1.465, and when we subtract it, 2 minus 1.465, we will have a 0.535 here. Will be our answer. Okay, so question 3, 4 and also 5 will be this way. You are gonna just prepare the given thing, apply the rules that you can use, and see what's the solution. Alright, let's finish the lesson with example 5. This will be our last one. So we have log base 2 of 6 is approximately is given this time 2.585, and we are estimating what's log 2 of 1296. Just like we did in example 3, we have a big number here, and we have to know what is 1296 equal to, especially related to 6. If you check it out, that is a 6 times 6 times 6 times 6, that's 1296. So that means that is 6 to the power 4. So it's better to start off the question with that. Log 2 of 1296 should be equal to log 2 of 6 to the power 4. And we know that we can just apply the product of the power rule here. The 4 drops in the front, so it will be a 4 times log base 2 of 6 here, like that. Okay, and we are given what is log base 2 of 6. That is 2.585, and we are multiplying this by a 4. That will be our answer. 4 times 2.585 should be 10.34. That will be our answer. So here we only applied the power rule. That was enough. So in the exercises set, you will see questions like that. So make sure you first factor the given number and see what is best for it, and apply the rule, and you will see the answer closely, and that will be it. Okay, so make sure you check out the homework questions. I posted it on the Google Classroom and also the Alex, and if you will have any questions, you know what to do. I will see you next week.